Hello everybody, welcome, thanks for watching. Uh, so, we've got some more science here. Like I said before, I know this channel's sort of a mix of different things, weird mix of Minecraft and music, but I'm leaning towards making it more science-based, just so you know, and I'm going to keep kind of going with following Anton here. I like him. I like his personality, but the topics he covers are right on with what I want to learn about and are interested in. So we have one titled, Like Earth, Mars has undergone an oxygenization event as well. Oxygenization. I have trouble saying that word, huh? Why would I guess that since it's red? I always assumed some sort of oxygen had been there to, impact iron. I just assumed that's what the red came from. But let's see what Anton has to say, because I know he knows a lot more than I do.
We're going to be talking about Mars and Martian discoveries. And this whole week I wanted to focus on various discoveries coming from this beautiful red planet, mostly because of the incredible success of the Perseverance rover that just sent us this beautiful first picture from planet Mars. Or essentially because of the success of the mission itself. As you probably know if you've watched the NASA stream or if you joined my stream at the same time, the mission was a complete success. The probe managed to land very successfully and almost exactly in the spot where they were planning to land. And because of this, it's also very important for us to understand what this mission is going to be discovering on Mars, and what we might discover in some of these unusual deposits inside the lake crater where the probe landed. And the first research I wanted to discuss is in regards to the ancient atmosphere of the beautiful red planet. It seems that there is actually something...
What's that big knob there? Is that Olympus Mons? I heard it's like 2.5 times the size of Mount Everest. Can you see that on the surface of Mars there? I bet it is. That must be it.
Similar between how Martian atmosphere was in the past to how the Earth atmosphere was as well. We know, for example, that one of the reasons why Mars has this unusual color is because it has oxidizing atmosphere. In other words, it's the atmosphere that produces rust, when iron mixed with oxygen create iron oxide or ferrum oxide. And for Earth, this oxidizing atmosphere existed here for at least 2.5 billion years. We know that all of this started happening after the very famous event, known as Great Oxidation Event, that started approximately 2.5 billion years ago. Here's a rough graph showing us that about 2.5 billion years ago, we start seeing the beginnings of this unusual stage. It progresses very slowly at first, and then explodes approximately 900 million years ago, reaching the peaks right around here, which is, I guess, about 400 million years ago. And so, for example, certain rocks that are about 2.1 billion years old, like this one right here, will often have these very specific patterns formed by these initial oxygenation events that acted on various metals inside the minerals. This event is also officially known as Great Oxidation Event.
That's interesting. I teach grade school, and we teach the different eras, Paleozoic and Mesozoic and Cenozoic, but even before the Paleozoic we talk about some, but we don't go back this far. Did he say 2.5 billion years is when that oxidation period happened?
Because that's when oxidation of various rocks on the planet began as well. Now the thing about this event is that we're pretty sure we know what started it. It was most likely cyanobacteria, or the early versions of bacteria that started to produce oxygen as a kind of a byproduct, or essentially as a waste of their photosynthesis.
So why don't we just, somehow recreate some of that on the surface of Mars? It's probably too cold. I don't know. Something like that, or synthetic, or something, and then let it go. Just let it. But, any of these processes that have happened on Earth have been millions of years, so I'm not sure that really helps us with colonization of Mars. I can't talk.
Now, for cyanobacteria back then, there was a lot of food available everywhere. There was a lot of carbon dioxide, there was probably also methane and a lot of other components that it can use for photosynthesis. And of course, there was a lot of light and a lot of water. All of this eventually resulted in cyanobacteria producing so much oxygen that it most likely caused a lot of other species to disappear completely, mostly because oxygen is also somewhat toxic to, well, pretty much everything, even to us. From what I remember, if the oxygen levels reach about 4 atmospheric pressures, in case of a pure oxygen at least, it also becomes toxic to humans as well. So in that sense, this great oxidation event, or the oxygenation event, it's a really difficult word to pronounce. Anyway, so this...
Hey, I was right. I don't know why. Oxidization. I thought it was oxidizate. I thought there was a D in there. Huh.
Event most likely resulted in the first very large extinction of various unicellular or very simple species, but it also produced a lot of new species, all of which started to use oxygen for their own needs. Now, this was a very monumental event for the planet, and it also most likely changed the color of the planet as well. The color of the oceans and possibly a lot of other stuff on the planet very likely was purple back then, and the reasons for this are explained in one of the previous videos somewhere right there. However, following the event, because of all of the oxygen and the lack of CO2 and possibly lack of methane in the atmosphere, Earth only stayed this way for a very short time, very suddenly turning into a snowball Earth, basically an ice-covered planet. This was because the lack of CO2 that was consumed by all of the cyanobacteria and the overabundance of oxygen lowered the temperatures dramatically. Now, all of this is not really a fact yet, but this is the most accepted version of the events. Following this, though, we know that Earth transformed again, eventually becoming habitable, and in the last 800 million years, the life here exploded. All of this was, of course, the events that followed the transformation of our atmosphere. Now, we're not really talking about Earth, though. We're talking about this little guy, Mars. It just so happens that we know that the atmosphere here is oxidizing right now, but was it different before? And it turns out, according to the study that as always you can find in the description below, the answer is yes. The atmosphere of Mars also transitioned from being reductive or reducing to oxidizing, and all of this happened slightly before planet Earth. And what's more is that this study is actually kind of brilliant in the way that it was conducted. It required no actual physical sample collection from Mars, and only required the surface scans that were essentially conducted from the Martian orbit by one of the wonderful orbiters in orbit of Mars that can easily scan Martian ground and even penetrate it as deep as 10 meters. We have very similar devices orbiting our own planet.
Really? How does that thing see down 10 meters? What is that, 32, 33 feet? That's incredible. Maybe P waves? Some sort of sonar kind of something. That's really cool. I don't know if you are following it. I mean, I'm not following totally, but the implication here is that Mars could have gone through similar transformations 2 billion years ago or so, and it turned out differently, but who knows? Maybe 800. I think he said that most of our life started about 800 million years ago, and I feel like the Ordovician part of the Paleozoic was what, 550 million years. I don't know. It's interesting that Mars could have had some sort of simple life form for a couple 100 million years, and then it lost it all, and then it's been taking this form since. Seems like it's a real possibility.
And we also have very similar devices orbiting around the moon. And for this particular mission, the scientists used one of the probes orbiting Mars and used an instrument here that uses infrared technology to penetrate the upper surface of Mars and is able to reveal various types of minerals and a lot of different geochemistry going on inside this ancient rock here by studying the molecular vibration of material present on the surface. And by collecting all of this infrared data, they then compared the similar data here on planet Earth, basically from similar satellites that orbit our planet. The scientists here used very similar volcanic rocks from the Hainan Island in China. These are volcanic rocks relatively similar to the rocks we found on Mars, and then compared these rocks to what they were able to see on Mars as well. And the conclusion here is pretty obvious. The conclusion suggests that Mars also had this oxygenation event sometime in the past, But in case of Mars, it most likely happened 3 to 4 billion years ago, so possibly 1 to 2 billion years before the one on Earth. But since we know the oxygenation event on Earth was biological in nature, there are going to be a lot of questions now trying to figure out what exactly happened on Mars to result in this relatively similar event happen here as well. And based on all of the observations of Martian surface, we know Mars looked very different in the past. Something like this, but probably even something a little bit more extreme. And all of this water and thick atmosphere was very likely at first reducing, so it probably had things like methane, things like hydrogen gas, possibly even carbon monoxide, but definitely very little carbon dioxide and very little or possibly even none oxygen. And these huge amounts of methane most likely also allowed Mars to have relatively warm atmosphere. Methane is a very strong greenhouse gas. However, then something changed. Mars started transforming, and well, it's obviously unclear what caused all of this, but it started changing quite dramatically and eventually started to oxidize as well. The atmosphere started transforming, became more oxidized, the water started to disappear, and eventually the rocks started to oxidize as well, turning the planet red as it is today. Which also of course suggests that the color of the actual regolith on Mars most likely was different color as well. All of this redness probably occurred way afterwards. But unfortunately there's very little we know right now. The only thing we know for a fact, and this is based on the observations reported in this particular study, is that, well, the oxygenation event seems to have happened on Mars as well. And by the way, here's what the scientists had to work with. This is the picture from Earth, and they compared this to the data produced from Mars. But what exactly caused the event, and also why Mars changed so dramatically afterwards, those are not the questions we can answer right now. It doesn't really have to be biological in nature, it could have had some other unusual or possibly still not explained phenomena happening. And this is why Perseverance rover might help us answer all of this once and for all. But if we do discover some sort of a bacterial life hiding inside the Martian regolith, and if we find signs of life from the past,
What is that word he's saying? Regolith? I've never heard that word. I don't know what that means.
it would actually answer everything all at once. All of the mysteries of Mars, all of the unusual observations, like for example the methane cycles, and a lot of other unusual observations like the results from the Viking mission on Mars about 40 years ago that may have discovered signs of metabolism, or at least some sort of a bacteria that was doing something on Mars, all of these signs would suddenly make sense. For now though, well, as always, extraordinary claims require extraordinary evidence. Perseverance might be the one to find all of these signs. For now, we don't really know. There might be a different explanation to what happened to this beautiful planet. But anyway, for now, that's kind of all we know. It's definitely exciting to know that Mars has undergone very similar changes to planet Earth, and it's also kind of important for us to realize that maybe, just maybe, this is actually what our planet Earth is going to look like in a few billion years as well. But that's not something we're going to know just yet. Until we learn more, well, check out the paper in the description below, subscribe if you still haven't, share this with someone who loves learning about space and sciences, come back tomorrow to learn something else. Maybe support this channel on Patreon or by buying the Wonderful Person t-shirt you can find in the description, and either way, I'll see you tomorrow, stay wonderful, and as always, bye bye.
Alright, what? Oh, is that some sort of ad? Alright. Let me turn that down, and I guess I've got to run that. We don't care about blinds. Okay, I see. He's just going to run some credits. I'm going to pause it there. So, yeah, that's very interesting. Right, the comparisons between Earth and Mars, I would have liked to have heard a little bit more about temperature differences, because I think that would play in a lot to all that. But, Mars is kind of like our little brother, right? And we, the more we can learn about it, the more we might learn about our own history. But as he suggested, we could possibly even learn about our own future, which is kind of important. Yeah, pretty interesting stuff. I didn't know most of that. I hope that perseverance. Wow, I've had a long day. It's hard to teach elementary school all day long. It's draining. I hope the rover can find some things. I hope. I mean, I'm sure it already is, but I mean, it'll be interesting to see all the information that comes back over time from it, and what more it can do than the previous rovers that have been to Mars. And I don't know. I don't know what the long-term plan is, but I'm kind of hoping that maybe the next mission to Mars has people on it. I know that's very, very risky, but at some point we might just want to go for it. And that's kind of my closing thought is, would you be willing to go on that mission to Mars? You got to think about your family and, all sorts of things, what the experience would be like, what it would take. Isn't it 2.5, 3 years, something like that, to go there and be there for a little bit and come back? I don't know, maybe they've sped that up, but think about all the factors of being the first to go to Mars. Obviously, you'd be one of the most famous humans ever, but, the survival rate isn't great. I don't know. Any thoughts on that? Feel free to leave them in the comment section below. And hope you guys enjoyed that. And thank you for watching and learning with me. And I learn something every time I do these kind of videos. It's just only been a couple times, but I'm going to keep it going. Thanks for watching, everybody.